Hi everyone and welcome to lesson 3. This lesson will be similar to the previous lesson, but going over how to plot and customize box plots, another very common plot type used in ecology when you want to visualize the association of a continuous variable between various categorical groups. These are also called box and whisker plots. First, we'll load the same data as before, the plant growth data. And just as a quick reminder, the one column, the weight column, represents the dried biomass weight in grams of each plant, and group represents 3 different treatments that were used when growing the plant. And these data include 30 different samples. Okay, so let's go on and make our first box plot. And let's do that by comparing the weight values between each of these treatments. And so what's neat is that the regular plot function will automatically create a box plot if the x-axis variable is categorical. And so if we look at the group variable in our data set, plant growth, we can see that this is a categorical factor variable with the levels control, treatment 1, and treatment 2. So if we do plot weight as a function of group data equals plant growth and run that, R will automatically create a nice box plot showing weight as the y-axis and these different groups as the x-axis. And there it is. So this isn't a statistics class, but here's a quick overview of the different parts of the box plot for your reference. So the dark line within each of these groups represents the median value. The gray box is the interquartile range of your data of each of these categories. So that means between the 25th and the 75th quartile. So 50% of all of your data points lie within this gray area. Then the whiskers, or these lines, mark the maximum and minimum range of the data, excluding outliers. The outliers are calculated, so like this point right here is technically considered an outlier, is calculated as any points that are greater or less than the interquartile range times 1.5. So essentially it provides a standardized method for labeling points if they're very far from all the other points, but it's a bit more of a conceptual, theoretical question as to whether these are actually treated as outliers or not. But this isn't a statistics course, so I'm not really going to go into that. But for now, I'm just explaining what these different aspects of the box plot represent. So now, as with the scatter plots, we can play around with these axes a bit. So let's copy and paste that here. And let's modify the X and the Y labels. So xlab, let's do treatment group. Ylab equals dried biomass weight in grams. So if we run that, there we go. Okay, but the labels for each individual treatment group are still not very clear. And to change those, let's actually change the data themselves to have category names that are a bit clearer. And so we can look at that by using the levels function in plant growth within groups. So again, this is our vector of groups, and it's a factor variable because you can see that here we have these 3 different levels, and the levels function just kind of extracts those 3 levels so we can look at them. Control or CTRL, TRT1, and TRT2. And so we can replace those with some names that are a little bit more meaningful. So let's say that we know treatment 1 is low sunlight and treatment 2 is high sunlight or a lot of sunlight. So we could maybe rename these as levels. So actually we don't have to rewrite this. So this function extracts the levels, but we can modify those levels by defining new levels right into this function like that. So let's define the new level names as control, highlight, and low light. Okay, something like that. Maybe we'll add a little dash here. Great. So now I ran that row, and now let's just take a look at, there you go. So see, these different levels have been renamed accordingly. So now if we run this same set of code one more time, run it right here. Now you can see that these labels have been renamed accordingly. So next, let's customize the design of the box plot a bit more by changing the color of the boxes. As I mentioned in the previous lesson, you should always strive for black and white or grayscale unless color is absolutely necessary for visualizing your data, and that definitely applies to this case. But I'm just going to show it to you here how to modify the colors just for completeness. So let's just copy that again here, and we will add in a simple argument of col equals, and again we can add in a custom color such as blue. You can add hex code colors. This will take several different forms of color values, but we can also use integer values that represent a series of different built-in colors. So in this case, let's do col equals 4, and when we run that, we get this nice blue color that fills in all the boxes. You can also remove the border around the boxes using box LTY, and that just represents box line type equals 0. So that removes this black border around the boxes. We can make the whiskers, instead of having them be dotted, we can make them solid using the whisk LTY equals 1, like that. And then we can also make all the lines just a bit thicker. So we can do that using whisk LWD line width equals, let's say 1.5. And then the end, this top, is also called the staple. So we can say staple line width equals 1.5. So that just made the lines just a little bit thicker, kind of making it all a little bit more visually appealing. And I kind of tend to prefer this type of look for a bit of a cleaner box plot. All right, so now let's change the orientation of the box plot. Again, let's copy that over. And what I mean by orientation is just add in this argument horizontal equals true. And that just turns everything sideways. In some cases, box plots for certain types of data, or when you have a lot of different categories, it becomes a little bit neater to have the box plots go horizontally like that. So great, that's it for this lesson. So far, these lessons should have given you everything you need for creating the two most common types of plots in ecology using R's built-in plot function. In summary, in this lesson, we went over building a box plot, using just the simple plot function, and the only difference is that the data on the x-axis are now categorical instead of continuous. We went over the different parts of the box plot and what they represent, and how to change the axis labels and axis names on the box plot, how to customize the color and visual style of the boxes and the whiskers, and finally, how to turn the boxes on their side. And with that, I hope you enjoyed this lesson. In the next lesson, I'm going to go over a simple method for prototyping and saving the plots that you make in R.